today we'll start talking about two-dimensional kinematics. So basically, this is the problem of what one can roughly think of. By the way, this thing has not been turned off. I'm sorry. Yes, I should have noticed. So, this is the story of projectiles. So, thus far we have been dropping a ball, we have been throwing up a ball, but in projectile, the motion would be two-dimensional. It's along x-axis and y-axis. So let's get into this a little bit. Suppose here you are, and you are on your castle. You're actually watching out for intruders coming to your castle. There is your whatever telescope, and suppose there are people coming to attack you. This is say one ship coming to attack you, and here is another ship coming to attack you, and let's say roughly speaking this is at twice the distance compared to this with respect to you, roughly speaking. So now you obviously want to defend your castle, right? So let's get into the problem. So what you do is you actually, fortunately, have a cannon, and you can fire your cannon to get to these ships. And let's say you figure out that because this one is nearer and that one is about twice as far away, you're going to use two cannons. So you recruit a friend of yours. One will be fired, let's say, at V0. And the second one would be fired roughly at 2V0. Alright? Sounds reasonable. You want to defend yourself. Who will blame you for that? So now what you do is you fire perfectly horizontally. So let's analyze the motion here. So here you are. At some level, let's say y equal to 0. According to the way we have done things so far. And you are firing from here, and you are firing completely this way. Let's just take V0 first. And this is where your ship is. So presumably if you fire this way, this is going to go and then gravity will pull it down, so it's going to hopefully hit the ship. So that should roughly be the projectile, quote unquote, that you will end up getting. So first question for you. So this is along the x direction, right? This is x. And this is y. So I should probably call V0x is equal to V0, right? That's the initial velocity along x direction. What about the initial velocity along the y direction? If the cannon is placed perfectly horizontally, what do you think that would be? 0, right? Vertical velocity should be 0 because we are firing horizontally, so we shouldn't have a vertical velocity. So therefore, we can safely conclude that if something is fired perfectly horizontally, then V0y must be 0. That's not always the case. But if something is fired or shot perfectly horizontally, that is the implicit information that you have been given. Just like you have been given information about if you drop a ball, the initial velocity is 0. It's very similar to that. This is actually a technical statement when one says that something is being launched horizontally. That means the vertical velocity is 0. Alright. So I want to ask you a question actually. So let's say that this cannon that was shot at V0 that came like this, and the one that was shot at 2V0 that came like this. So let us try to guess how much time it would take for the cannon to go from here to here and from here to here in the second case. If we try to do that, do you think that these two cannons will hit the two ships at different times or at the same time? Why should it be same time? Gravity is the same. Does everybody agree with that assessment? You think it will come? You think it will reach at the same time?
If you're doubling the distance and then you double the velocity, it is the same as the single distance, the single velocity.
That's what you think will happen. Do you have a technical reason also for it? No? Yes?
Just since D was speaking, D and B
I think, yeah.
I think they'll land at the same time because they both start at the same height. And there's no
Yeah.
initial velocity.
Okay, good. I think most of you guys are beginning to get the picture. So the idea here is that for Canon 1, for Canon 2, let's say that as far as the vertical motion is concerned, I can certainly write the distance drop, let's say minus y, is equal to minus 1/2 acceleration to gravity g times, let's say, T1 squared. Now this comes from the kinematic equation that we know very well, because initial velocity is 0, the first term, which would be v0y times t. So the equation I'm thinking of obviously is y equals v0, or in this case v0y times t plus 1/2 at squared, let's say. So here this term is 0, so therefore I should be able to write this. I can get rid of the minus signs. If I have minus signs on both sides, I can divide by minus 1 and make them plus. For Canon 2, on the other hand, once again, the height it comes down is also y, and it's 1/2 g, now t2 squared. And you can immediately see that the time of fall would be the same for both cases. So it's 2y over g here, square root, and it's also 2y over g there, square root. So therefore, the time of fall for both of these cannons, okay, is exactly the same. The cannons would land at the same time on the two ships. Okay. Now, let me just make a point here that this is a very important observation, and very often I'll be checking up on you to see if you can actually, almost without thinking, realize that if something is dropped, the time of fall is square root of 2y over g. Because that's always going to be the case. In fact, I think I've already given you something like this in the quiz. Alright, so in this problem you can easily see then that the time of fall in the two cases should come out to be the same. Now, that doesn't mean that the horizontal distance to be covered would be the same, obviously. Because in the horizontal motion, we know very well that there is no acceleration, right? There is no acceleration in the horizontal direction. All the acceleration is along the vertical direction. So as far as the first guy is concerned, let's call it x1, that's the horizontal distance traveled by the first cannon. So that will be v0 times x, which is equal to v0 times t1. So therefore this would be v0 times 2y over g square root. And similarly, x2 would be again v0, twice v0x, or v0x is generic, I guess, t2, so that will be twice v0 times 2y over g square root. So I can actually figure out how much horizontal distance is traveled just from knowing how high I am positioned, what is the acceleration due to gravity, and what is my typical velocity for the cannon. Okay? Any questions? Yes.
Is it 2 times the initial velocity of the second?
Because I just said that, right? The second cannon is being shot at twice the initial velocity. Yes. Any other questions? Okay, very good. So before we get back sort of deeper into the issues involved, let's do a simple problem. Suppose then that you want to jump into a pool, and there's a little ledge here, and here is the pool. Suppose this ledge is 2 meters. And here you are, running towards the pool to jump into it. So let's say that your initial velocity is some unknown, which is v0x. And you don't know what this v0x is. All you know that this height is quite big. It's about 30 feet. It's about 10.0 meters from the water level. From this. You can basically assume that this is the level. Okay? Actually, you can assume this is at the water level, just to make things simple, without really losing it. Okay? So here you are running around, you want to jump into the pool, and you obviously want to make sure that you don't land here and injure yourself. So that's the trajectory that you want. So given that you are at a 10-meter height and the ledge is about 2 meters, it's not drawn to scale obviously. The question may be that at what velocity must you be running? All right. So I want to find out what v0x is. So the first thing I'll observe obviously is that v0y, I'm running horizontally, v0y must be 0. So therefore I can immediately write that minus 10.0 meters, just right there, is equal to minus 1/2. In this case, g would be 9.80 meters per second squared times t squared. So if I approximate this by, let's say, 10 meters per second squared, just to simplify my life without losing very much, then I can immediately see that t squared is going to be 2, right? Because I can put a plus here and a plus here. Then these two 10s cancel out. So I have half t squared equal to 1, so t squared is equal to 2, which means that t is square root of 2 seconds, which is roughly, as we already know, square root of 2 is 1.4 seconds. So I can already calculate that very easily. So once I know my time, I can immediately calculate what velocity I need to clear 2 meters. So in this case, I would be using the simple distance is velocity times time relationship. Distance is 2.00 meters. Okay, so velocity I don't know. This is something I need to find. I called it v0x. And t is already square root of 2 seconds. So therefore, it's a no-brainer right now that v0x is going to be 2 divided by square root of 2 meters per second. So that would be square root of 2 meters per second, or approximately 1.4 meters per second. And I can ask you to calculate this in kilometers per hour or something to make such conversion. So that's a very simple problem that exemplifies something that we have learned in the context of a regular typical problem that you might encounter. So this would be at the easier end of things, where you're simplifying the fault line and then find out what horizontal distance is involved, and from that figure out whatever else that you need to know. Questions? Anything that's not clear here? Yeah.
You get t squared.
Oh, from there, from the equation. So this is, I'm using this equation here. You get it, right? Any other questions? Very good. So, what do you think the path of this projectile would be? What kind of a curve do you think it would be? There will be a parabola. That is correct. Now, but what we can actually check how this works, because it's, in fact, we already have, excepting I didn't really point out to you because I was going to wait for a little bit. But let's go back to that statement. these set of statements I made here, I pointed out in this problem, right? In this problem, the horizontal distance traveled by the cannon, x1 for the first case and x2 for the second case. If you look at that, then you find that x1, let's take the first one. So x1 is v0 times 2y over g square root. So if I were to get rid of the square root, then I would have x1 squared equals v0 squared over g times 2y. In other words, I'll have an equation of the following form. So the equation that I have would be x squared, in this case let's say x1 squared with some constant times y. Because v0 is a constant, g is a constant, 2 is a constant. So it's some constant times y, which means that for every value of y, I have potentially two values of x that can come out. You may not need both the values of x, but the equation tells you that for every value of y, there are two values of x that are allowed, which is really what the equation for a parabola is. So in this case, for example, the flight is like this. So it turns out, so this is your x and this is your y. For every value of y, this equation gives you two values of x. So one value of x that you will get for this value of y, let's say here, this much, is this value of x. Or if you measure from here, whatever. All right? However, it's also telling you that this curve is symmetric in plus x and minus x. So in other words, it actually is all right. Well, not exactly symmetric, but if I could think of it like that, because then I would indeed get for every value of y, two values of x. One would be here, that let's say would be some minus x, some number, let's say minus x1, on the x-axis, and this would then be plus x1. So that's why it's a parabola. So just by doing the analysis that we have done, we can actually deduce that every time you throw something up, as long as there is no air resistance, the motion will be along a projectile. Okay, so we are doing half a projectile. So here we have done half a projectile. There I have done half a projectile, just to keep things simple. But in general, what we have done, everything works for the full projectile, which we'll also do. Any questions so far? Okay. Yeah.
When you squared
Yeah.
how did 0 go above g?
No, it didn't. This is v0 squared over g. And this is 2y. 2y is upstairs in you.
Yeah, so why did that come out of the...
I squared everything. So square root
Yeah.
squared is 2y over g, right? So what's going to be? Square root of a number.
Just because it's the square root.
Yeah, you have to square it.
So then why is it not above the g? It's still
Okay, so you have x1 is v0 2y over g. This is the square root. So if I do square, I do square, and I do square, right? So x1 square is v0 square divided by g times 2y. Alright? You are uncomfortable with the square root here, or what is
the square root? I'm just wondering why you took 2y out of the parentheses.
Because the y is the variable, that's why. Ultimately, you are trying to connect the x variable and the y variable, right? So you want to separate that y variable so you can dump everything else within your constant. Because what we are looking for is the structure. That's the structure that we have. That's all we are seeing. So those constants are taken care of and they're fine. But the details of those constants really doesn't matter beyond the point, because the point I'm trying to get across is that you'll have a parabolic trajectory involved. Okay? Yes?
Just a quick question about every y has two x's. What about 0? Doesn't it technically hit 0
So
for each
Okay, good question. So if y is 0, right, then you have only one point, x is also 0. So in this case, the way we have it set up, 0 is at the origin. That's the way we have it set up. And that kind of makes sense because the way where we set up the origin is ultimately something that we do based upon convenience. That's something we decide most of the time, or almost every time, right? So I can always set my x equal to 0 to be the point where y is equal to 0. Sometimes it is not the most convenient thing to do, so I may move the parabola up or down, in which case y would have a value as opposed to being, both being 0 at the origin. But in general, in this case, for simplicity, I set both to 0 at the origin. Any other? This particular chapter is the beginning of a lot of trouble for a lot of students because this particular chapter quickly builds up. So I'll be assigning you a lot of problems, and many of them are not going to be in the book, okay? Because I want to get you guys enough exercise on this, because this is where people stumble like crazy. One of the things that we are doing, I don't know if you have consciously noticed that, is we have broken down the original motion, the parabolic trajectory, into two pieces that you obviously have seen, the x motion and the y motion. So what is the variable that connects the x motion and the y motion? And did anybody offer an answer? What is the variable that connects the motion along the x direction and the motion on the y direction?
Slope.
What are your variables? You have x, y, v, meaning vx and vy. You have time. You have all these variables. So what variable do you think connects the x and y motion? Time. Actually, this is something that I did here implicitly, and at some level I'm sure you guys got it, but it's important to realize that the way we are doing it is we are connecting time. So here the time of fall along the y direction is being connected to the motion along the x direction. So once we connect the time of fall in the y direction to motion along the x direction, I actually get the full trajectory. So the x and y motions have to be connected by time. Otherwise, you have broken up the problem into two pieces, but you are not connecting them back up. So you still have the x motion going along and the y motion falling along, right? To be able to piece them back together and get all the variables tied together to get the projectile motion, the unifying variable here is time. So please keep that in mind. So let me ask you a question, going back to this diving problem. Suppose that you are on a planet where the acceleration due to gravity, let's call it g again, is very, very large. Let's say g goes towards infinity. So it's very large. Infinity is a very large number. So in other words, suppose you are hanging out in Jupiter. So your g goes to infinity. Actually, well, g is very large. You have no chance of surviving in Jupiter if you could get there. So what do you think will happen as you run to go towards, in this case, whatever swimming pool is in front of you? Will you be able to make a similar parabolic pathway? No? What will happen? Go down like a rock. That's about right. So if g is very large, so if the downward acceleration is very large, then of course the trajectory, it will still be parabolic, by the way. It will just be like this. And you will end up on the ledge. All right? Now what happens? Let's say if you do the same experiment on the International Space Station, where there is no swimming pool, I'm afraid. But suppose you do this in the space station. What do you think will happen?
Your trajectory will just stay horizontal.
It will continue to stay horizontal. It will not go down at all. So clearly then, over here, there are two kinds of extreme motions built in these are the things that I want you to observe. One is that if g were large, if g goes to infinity, whatever that means, you'll just fall like this, and if g goes to 0, then you'll continue to go straight like that. Similarly, let's forget about g. If my v0x goes to infinity, or v0x becomes sufficiently large, then again, I won't even go down for a very, very long time. I'll continue to go horizontally, because it will take gravity a great deal of time to set in any measurable way for you to be going downward. So, if you want to launch a rocket like SpaceX does these days, all you need to really do is overcome gravity. And you know that that's a pretty expensive business because you need a fair amount of fuel to be able to do that ordinarily. All right, any questions so far? Any other questions? Anything that's not clear? Please do ask questions, because this is your best opportunity to get things clarified. Yeah.
Going back a ways, we have the VOX equals 2 over the square root of 2. How does that become equal to just the square root of 2?
Because 2 is square root of 2 times square root of 2, right? So, square root of 2, by definition, times square root of 2 is 2. That's one. So, if you divide 2 by square root of 2, you are only left with square root of 2. Because that would be, like root 2 times root 2 divided by root 2, right? Right. Any other questions? No? Did I ask you to do it tomorrow, Thursday? You'll do it this week? Good. And I want to see that confidence. There are quite a few nodding heads. All right. So let us look into the trajectory business a little bit more, explicitly here. So let's say you have a height here. Height is y. Same thing that we have done before. Okay, and we have a v0x. Okay. And let's say, in general, we also have a v0y, right? And we have the acceleration due to gravity g. Then I can write that minus v final of y, let's write it like this. So as this fall, the final velocity on the y direction is minus v0 of y minus gt. So I'm obviously using our equation number 2, I think, originally, which was that v final is v0 plus acceleration times time. This was one of our equations. For those of you who are still uncomfortable with this, please don't be. This is the time to make sure that you pretty much get everything, or let's call it x. So x is v0t plus 1/2 t squared, and so on. So we did all these equations. So here I can, for example, see that v final y is minus v0y minus g times t. And I can essentially, if v0y were not there, then this t would be okay. So basically, I can also see that v final y would be g times t if this piece is not there. Right? I can put a minus and a minus here. If I kill off this piece, if I set this to 0, then from here I can see that I can write minus v final, which implies minus v final y is minus v0. Sorry, is minus 2. Let me not jump a step. G times 2y over g square root, because that would be the time involved with I have to drop. Are you guys okay with this? You see what I did? I just killed off the initial velocity along the y direction. Then v final y is just this amount. All right? Why is it 2y over g square root? It came from here. Because then it becomes a free fall velocity. So it's 2y over g square root. Okay. So if that is the case, then indeed if I have some initial velocity added on, I should also be able to write in general that if I have v final y with v0 y turned on, that will be v0 y, whatever that is, plus the free fall time that it already takes. So final velocity will be simply the original velocity that will be acquired if it were free fall plus whatever additional velocity I supplied when I began this. The reason why this is okay is because if you recall on the second day of the lecture, we actually, in fact, first or second day of the lecture, I actually did this by working it out on the board and so on. I plotted a graph and said that I made a table and I showed it to you. So if you have forgotten that, go take a look at the lectures from week 1. So this is something that we can easily see. Now v0x on the other hand doesn't change, so v final x is always equal to v0x. So therefore, I should be able to write in general v final squared, which is sum of the two vectors. So v0x, sorry, v0x squared plus v final y squared. Does this make sense? Are you guys completely lost? If you are, then raise your hand. You should be quite lost. People who are not raising their hand, they may not have a clue as to which is even worse. So, be honest. What we are trying to do here, if you want to go back to that picture, is that this thing is coming down like this, right? So, initially, this was the velocity v0x, and then there was some kind of v0y, whether it's 0 or not. That was the initial case when the motion started. Now, as the motion progresses, this part is unaccelerated. So every time this part remains the same length as this, but the vertical motion is speeding up because of gravitational acceleration. So this means that over here, let's say there was no v0y, but over here there will be a substantial v0y. So much so that the resultant of these two vectors, if I could draw it properly, I have to make it longer obviously, is actually going to be in this direction. And similarly, if you want to find out the velocity here, you again have the v0x and a very long v0y such that you get a resultant in this direction. So therefore, we are actually doing vector reconstruction in this case to find the final velocity. Yes?
Why does everything suddenly get squared?
Yes, that is a question. I was going to ask you that question. Why do you think it gets squared? Very easy answer.
So that might be
No. No. When you algebraically add vectors, what happens? Do you remember that? What did we do? So when we were algebraically adding vectors, what we were doing was, let's say, let me go here. So we had a vector like this, let's say, and then we had an x-axis and a y-axis, right? So let's say this vector is A, and then what I did is I dropped a perpendicular, so this became an AX, and this became an AY, and I argued that AX, if this is theta, is A, meaning the magnitude of A, if you will, cosine of theta, and AY is A sine of theta. Do you remember this thing that we did? This is how we resolve vectors. Resolution of vectors is critical at this point to your survival in the class. So you should be very familiar with resolution of vectors. So now you see, if I want to find out, if I want to relate this A vector to Ax and Ay, I actually have a right triangle. I have Ax here, Ay here, and A here. So therefore, I should be able to write modulus of A squared, which is the magnitude of A, right? If A is 5 meters and magnitude is 5 squared, 25, must be equal to Ax squared, which means this side squared, plus Ay squared, which means the vertical side squared, whatever 0. That's why you get the squares. So over here, we have a very similar situation. We have V0x in the horizontal direction, and we have V final y or whatever, Vy in the vertical direction. So if I want to get the resultant vector, I have to do the exact same thing. So I'm actually doing a Pythagoras theorem based addition of the two vectors, just like that. In this case, it looks different. I have a V0x this way, and I have a Vy or V final y, whatever you call it, that way. Instead of looking the way you have, this is along the x-axis, this is along the negative y-axis. I can make my negative y-axis point down. I can make my y-axis point downward. That nothing changes as long as I know what I'm doing. So then I can see immediately that the resultant would be in this direction, and the magnitude of this resultant would be V0x squared plus Vfy squared, which is what I have done here. Okay? Questions? Unless you tell me what the questions are, I can't get inside your mouth. Vf is the resultant vector's magnitude. So yeah, so Vf with the vector sign is the resultant vector. But when I write Vf without putting the vector sign, what I mean is the magnitude of the vector. Okay? By default, that's what it means. That's a simplification that is often any other? Yes.
So even in this problem, your final velocity velocity.
Yeah, because there was no acceleration along the x direction, right? It's a horizontal motion. There's no gravity. Yes.
Just explain again why a vector squared equals ax squared plus by.
I'm using Pythagoras theorem, right? So everything in trig has to do with the right triangle at the simplest level, right? So that's my transform. So this is A, this is Ax, this is Ay, and my Pythagoras theorem, A squared is Ax squared plus Ay squared. Any other questions? Yes.
Why is it that for the vectors,
Speak louder.
why is it for the vectors you're using the initial for x but the final for y?
Because the final for x is same as the initial for x. There is no acceleration on x. Okay. All right. So what I'm telling you then is that the V final itself is therefore relatively straightforward to calculate because I know how to find V0 x, that's typically given, let's say. I know what V final y is from computing the vertical piece of the motion with the acceleration due to gravity, which is what I was showing here. So square that. If you square these two, then you would get the final velocity of the projectile, square the final velocity of the projectile at the time at which you know this quantity. This quantity, of course, doesn't change in time. So therefore, since V final y is changing as the thing is falling, your actual V final would also be changing. And that shouldn't surprise you, because if you jump off, let's say, some height with some horizontal velocity, then essentially, lower you go, faster and faster you will be naturally moving, right? So therefore, the V final magnitude is always going to be dependent upon the magnitude of V final y itself. What's going on? You guys are okay? Or? You need to ask more questions. The silence is eerie. It's bothering me because I know that all the ones who are silent have a strong chance of screwing up what's coming ahead, which is exam 1. And there are a bunch of people at the back who are busy doing their homework or doing other things, which also worries me. Not that I'm going to bother you very much, but if you keep doing that, unless if you're sure what is going on, that's okay. But if you're not sure what's going on and you are doing something else in this class, Lord be with you, because you have no idea what's going to happen next week. And this is not an effort to scare anyone. I'm just trying to make sure that you guys don't unnecessarily screw up. So in other words, I can now do a few other things. I can point out that I can write this v0x squared plus v final y. I already have an expression for that. Over here actually. Wait a minute. Where v final. Oh, here. So v final y, I have an expression for that here. So I should be able to write v final y squared as follows. I should be able to write this is v0y plus 2gy square root square. This is v final square, which means that in general, I should be able to write v final as v0x squared plus v0y plus 2gy squared whole thing squared. And if v0y is 0, then of course it will simplify to v0x squared plus 2gy, right? Square root. This would be the final in that. Yes. Why did I do that? Why did I do what I did? Did I screw up intentionally or? G divided by root G is root G, right? So I pulled the, so I had a G here and root G here. So G divided by root G is therefore root G on the top. So that's why it became square root of 2G. Alright or no? I know it looks ugly. I'm not going to make any bones about it. It looks ugly. The reason why it looks ugly is very simple. The reason why it looks ugly is because I'm working out a perfectly general case where you can have all these quantities have whatever numerical values are appropriate and then be able to calculate v final. The moment you consider the case where there is no v0y, which means there is completely horizontal velocity that's kicking off the projectile motion here, then this term goes away, which means this term goes away, which means it immediately becomes simpler. So that's okay. I mean, you shouldn't get scared when you look at things that are algebraically a little bit daunting. All right. So everything is here, for example. So if I want to turn off gravity, set G to 0, then v0x squared square root is v0x, which means if the final velocity, if there is no gravity, it's still v0x. By the way, that's a point I made a little while ago, because if there is no gravity, you just keep on going. So the final velocity would be same as v0x. So that particular result is actually buried over there already. Similarly, if v0y is 0, you are just left with square root of 2gy, which, by the way, is what you can get from a direct fall problem. In fact, that's something I didn't get that. I didn't show it explicitly again, but that's what it is. So all the limits are in there. Now, there is something that I haven't told you in this problem. What is it that I haven't told you? I've given you the magnitude of the final velocity, but I haven't given you something else, which is to know a vector, what do you need to know? Magnitude and direction. So did I give you direction yet? I haven't given you direction yet. So we need to find the direction, right? So let's say by the formulas that I was playing with, I can think about a tan of theta. Tan of theta of what? So then you got to ask this question, tan of theta of what? In this case, if you look at this picture, this is my v final of what? This piece, this vertical piece. This is my v0 of x, right? So therefore, this is my right triangle. And in this case, what I'm talking about is the tan of theta can be this angle, for example. And I can say that tan of theta is defined with respect to the horizon, downward. So tan of theta can be, since it's tangent would be opposite over adjacent. So therefore it will be v final y divided by v0x. That will be your tan of theta. From here you can calculate theta. Now you have to be really careful because this is where almost every one of you will make a mistake. So let me just tell you where you have to be careful and why. If you look at the picture that I drew, I have a triangle where this is my v0x, and I have a triangle where this is my v final y, right? So therefore, this is the parallelogram I completed, and this is my diagonal. So this gives me my actual v final, and I told you how to calculate v final on the extreme right lower board, and I've also told you what the angle theta must be, and theta is 0. And you basically come to the conclusion that tan of theta is Vfy over v0. Yes?
How do you know if it's east of south or southeast? Which one?
By drawing a picture. That brings me to a very important point. That whenever you do these problems, or whenever you do any physics problem, it is imperative that you first draw the picture and lay out what's going on. Unless you have kind of the movie of what's going on in your head, there is a near 100% chance that you will make a mistake. So the way to do these problems is making totally sure that you actually have a physical picture in your head of what's happening. So in this case, that's also the reason why I'm showing you this, because you see, this is the horizontal level. Theta I'm going to get is going to come out a positive number because I've taken this to be positive, taken that to be positive, and not making both about different sides. But the fact is that in this case, tan of theta that you will get is going to be v final over v0x, and this quantity probably will come out with some positive number. So what does that mean? That would typically mean that you will get a positive theta. Let's say you got a theta, just for the sake of argument, let's say theta is 28 degrees. Okay? So you have to be careful now as to how you report the result. It's fine to know that theta is 28 degrees, but you got to see that theta is 28 degrees below the horizon. So you have to be able to say clearly that theta in this problem is 28 degrees below the horizon, or theta is minus 28 degrees. The reason is that normally in trig what we do is we go from the x-axis, right? We go from the x-axis leftward to the y-axis, leftward to the minus x-axis, and then downward to the minus y-axis. And this is the route we take. So it's an anti-clockwise route. So in other words, theta is positive when going this way, but theta is negative if you are trying to go that way. Because the positive direction is the anti-clockwise direction in which you are going. So these are things that take a bit of time for students to get comfortable with. This is the reason why those practice problems that I assign are so important, because I'm going to be testing you exactly on these things as we go along, just to make sure that you are getting it. So if I'm reporting it, I'll be very careful to state what I found. I'll be very careful to say that, look, this angle that I found is actually 28 degrees below the horizon. And draw a picture to be clear. Or say that theta is minus 28 degrees just to make the point that it's below the horizon. Okay? So these are things where you need to use your judgment. Physics is very different from math in that regard, because yes, you do a lot of math, you need the math to get the work done, to understand what's going on. But beyond that, you also need to understand what it is that you are doing and be able to explain that and use the appropriate science and so on just to get it right. Yes.
Tangent, that's supposed to be VFY.
VFY. I'm sorry. Yeah. Thank you for pointing. Yes. Any other? Yes.
Why did we start calling VFY
Oh, because VFY is the final velocity along y. V0y is the initial velocity along y. So as it starts to fall, V0y is the velocity with which it starts, and eventually it speeds up. So the final point where we are taking the final velocity is VFY.
Okay, and VF is the result.
Yeah, it's the full result. So Vf squared is Vfy squared plus V0x squared. Right? It's made out of both x and y. That's going like this. Vfy is only going vertically. Picture. All right, what's happening? Questions? Make sure that you go over this material thoroughly and carefully, okay? So nothing here, unfortunately, is very simple. Now, there are some things at this point that are relatively easy to do, so let me try and do that. Hopefully that will also help clarify things a little bit. This chapter is the first of the difficult chapters and really gives students a fair amount of trouble, because students coming from chapters 1 and 2, they underestimate the difficulty involved in this chapter, and they tend to really fall apart. And I have a lot of people that end up, unfortunately, resigning at this time. So I'm forewarning you, be advised. This is one of the areas that we have already come into that is challenging. I don't want you guys to slide off here. So be very serious, push yourself, and you'll be fine. But if you take it casually, you think, oh, it's okay, it's another chapter, I'll do it later. Okay, you're basically not going to get it. I'd rather tell you the truth than dance around it, but that's what's going to happen. If you need help, we're always there. You know that by now. We have to figure it out. All right, so let's do a relatively straightforward problem where I would actually do the full Brilliant-Child problem in the following way. I would draw an x-axis here, a y-axis like this, and let me say I launch something in that direction. So let me give it a velocity to be 0, and let me give it an angle here, which is theta. So if I kind of guess what the route would be, it will go up. It will hit a high, and then it will start to come down. Right? That's what we would expect to happen. We know darn well that this is a parabola, because we have already discussed that over there before I erase this. This is not the perfect parabola I can draw, so I apologize for it. Maybe I should draw something like more like this, but that works. All right. So one of the things we can easily see is as this thing goes up, gravity acts downward. We are going to resolve the motion along a vertical piece and a horizontal piece. The horizontal piece here is V0 cosine of theta, given theta is defined like so. And the vertical piece is going to be V0 sine of theta. Again, by resolving the right triangle involved. This is the right triangle that I can draw. So this is V0y, which is V0 sine theta. This is V0x, V0 cos theta. No acceleration along x. And there is g acting downward along y. So let's consider the vertical motion at a table here. So vertical motion, your V0y is upward, so I leave the sign positive, so that's V0 sine of theta. The acceleration due to gravity is minus g. No problem there. I don't know what in general y is, and I don't know what in general time is. I do know that time must connect all the pieces, right? We already discussed that. So that's vertical. as far as horizontal motion is concerned, that's quite straightforward. And here we have v0x equal to v0 cos theta. And the acceleration here is 0. And we have x and t, our quantities of interest. So let me go to this board here. So, a couple of things you can immediately see. Let's say the height, maximum height it will get up to, let's call this h, this maximum height, and we can easily calculate that. So we know that if we just consider the vertical motion, then v final y would be what? If you just consider the vertical motion. So it's going up. What is the v final y? 0, because it has to stop before it turns around. So that's a giveaway. That's how we should be able to get the h. So v final y is 0. v0y we know. So at this point, it's a very easy problem. We have done these problems quite a few times. Acceleration is minus g. So the question is, what is the maximum height reached, which is what we'll call h. And since we don't have time, we don't need to get time, we can immediately see that v final y squared is v0y squared, which is given. This is 0 minus 2 g times h. So this term is 0 because it has to stop, which means that h must be, if I take it to the other side, get rid of the minus signs, and v0 squared over 2g. And that must be my height, right? So this then means that since so v0 y squared, v0 y squared. So v0 y squared is going to be v0 squared sine squared theta 0 or theta, and this is 2g. So therefore, my actual relationship that ends by the way, don't memorize this. I have a lot of students basically trying to memorize this formula. From time to time, it can be handy, but in general, it's more of a nuisance than otherwise. I'd much rather be able to have you able to quickly see where it comes from and be able to work it out anytime you want than unnecessarily memorize it and forget how you got there. Because most of the time, I won't ask you to actually calculate the height. That's just too simple of a question to ask. I know exactly what happens. So what I typically ask you is, this stuff is involved in the calculation such that you have to work out the pieces that led up to it. So this is a formula that is interesting and important because it tells you something. It tells you that to get to the maximum possible height, let's say h max, I give it a name, that must be v0 squared over g, because the maximum value that sine theta can take is what? Sine theta goes between what and what? No. Sine theta goes between what and what? Don't give me the angle. 1 is 1 of them. Huh? Negative 1. So it goes between minus 1 and plus 1. Can't be outside that now. So if you square the maximum value of sine theta, what happens? 1. So therefore, the maximum value sine theta can have is 1, which means that this is the maximum value that I can take, which will only happen when you have sine of what? 90. Sine 90 is 1. Alright, so if you throw something vertically up, that will be when you will get the maximum height. That's what it's telling you. Which, by the way, makes a lot of sense. Alright, so I'm going to stop there, and we will carry on with a few other things, and then some problems on Thursday, and then move on to Newton's equations. All right, get ready for the quiz.